Before we talk about relations, go ahead and plot the point 2, -3 on this graph. Okay, so what's a relation in mathematics? It's a set of xy coordinates, also known as ordered pairs, because this is a pair of numbers. Relations are often represented as tables, like this one here. The first column contains the x coordinates, and the second column has the y coordinates. So the first point in this relation is this row here with an x-coordinate of 2 and a y-coordinate of -3. As you already found, that's this point down here. Go ahead and select the 3 remaining points in this relation. Nicely done. So this is the graph that represents the relation in this table, and it consists of these 4 points. Now, relations can also be expressed as equations involving x and y. Here's an example. Y equals x. So this equation represents the relation where the y-coordinate equals the x-coordinate. And one point in this relation is 4, 4. Its y-coordinate equals its x-coordinate. They're both 4. Can you identify a few more points that are part of the relation y equals x? Right, so for these 3 points, y equals x. And if you were to plot all the points in the coordinate plane that are part of this relation, you'd get this line, which, sure enough, is the line y equals x. So relations don't have to be equations, they can also be inequalities. So another example of a relation is y is greater than x. This relation includes all the points whose y-coordinates are greater than their x-coordinates. One point in this relation is 2, 4, because the y-coordinate, 4, is greater than the x-coordinate, 2. Select the other points here that are part of this relation, and be careful when working with negatives. Nicely done. So these 3 points are part of the relation y is greater than x. And here's the complete graph of this relation. It's this shaded region, all the points that are up and to the left of the line y equals x. Okay, let's look at one more relation, represented by the equation x squared plus y squared equals 25. One point that satisfies this equation is this point over here, -4, 3, because -4 squared gives you 16, and 3 squared gives you 9. Adding those together, you get 25. So this is one point in the relation. Select the other points here that are part of this relation. Excellent work! So here are a few more points in this relation. 3, 4, 5, 0, and 0, -5. If you were to plot all the points in this relation, here's what you'd get. And it's a circle centered at the origin. Pretty neat, right? We'll be exploring equations that represent circles in a later lesson. So to summarize, a relation is a set or collection of xy pairs and can be represented as equations like this one, as inequalities, as graphs, or as tables like this one. Now, recall that a relation is a set of xy coordinates. Here's a table for a certain relation. Go ahead and select the 3 coordinates for this relation. Right, here are the 3 points for this relation. Now, you'll often hear x-coordinates as being inputs, and the y-coordinates are called outputs. Now, consider a relation that takes the input and adds 2. So when the input, or what goes into the relation, is 1, the output, or what comes out of the relation, is 3, right? So this relation took the input, added 2, and that gives you an output of 3. If you were to put 2 into this relation, it would again add 2, giving you an output of 4. Now, if you were to put 5 into this relation, what output would you get? Exactly. When the input is 5, the output is 2 more, so that's 7. Now, let's compare this table to the relation you graphed earlier. For a relation to be a function, Each input must give you exactly one output. If you look at this table on the left, an input of -2 gives you a 5, but in the very next row it gives you a -3. So this relation is not a function because one of the inputs gives you two different outputs. But this relation that adds 2 is a function, right? Suppose you again tried an input of 2. What output would you get? Well, you'd add 2, giving you 4. So when the input is 2, notice that you get exactly one output, 4. So not only is this a relation that adds 2, this is a function. Next, take a look at these three tables. Now, it's not immediately clear what the rules are for these tables, but by looking at them carefully, can you tell whether or not they can be functions? Right, so in this first table, an input of 3 gives you a 2, but in the next row it gives you a 1. So this relation is not a function. In the second table, you have 3 different inputs, so this can be a function. And in the third table, an input of 4 gives you an output of 7, and then another input of 4 gives you the same output of 7. If you got a different output in this row, something other than 7, then this would not be a function. But because these two outputs are the same, this table can be a function. Next, here's a slightly longer table with some inputs and outputs. Now, in order for this relation to be a function, what must this missing output down here be equal to? Keep in mind that the input here is 3, and 3 is also an input for this row up here. Precisely. The first time you put 3 into this function, you got 8. So if this really is the table for a function, when you put in 3 again, you have to get 8. Next, take a look at these two tables, which appear to be very similar, but are quite different. Only one of these can be a function. Which one? Right. For this table on the left, you get the same output of 7 every time. But for each of these inputs, 4, 5, and 6, you're getting exactly one output. It just so happens they give you the same output. But for this relation on the right, the first row says when you put in a 7, you get out a 4. The second row says when you put in a 7 again, you get out a 5. So it can't be a function. And the third row gives you yet another output for the same input. So this table can be a function, and this one can't. Finally, let's return to our function that adds 2. Here are a few inputs and outputs for this function. Go ahead and select the points representing these coordinates. Nicely done. So here are the 3 points from this table. Suppose we were to add more rows to our table. For example, when you put -2 into the function, you get out -2 plus 2, or 0. And that's this point over here, -2, 0. If we put -1 into the function, we get out a 1, and that's this point. And if we put a 3 into the function, we get out a 5, and that's this point up here. We could keep going, graphing more and more inputs and outputs for this function, and eventually you'd see that they form a pattern, this line. So this line is the graph that represents the function that adds 2. You might also recognize this as the graph for the equation y equals x plus 2, with a y-intercept of 2 and a slope of 1. In later lessons, we'll explore the graphs for all sorts of different functions and see how they relate to equations like this.